Bene, potete partire.
Okay. So just a tech check. Could you see me right now? Am I visible? Yeah. Okay. So thanks a lot for being here. Welcome to this first edition of the CodeFest. As we all know, at this moment of the festival, this first edition is an online edition of the festival. Of course, we would have preferred to have a physical edition, but COVID-19 has forced us to adapt to different plans had to be devised, not only us, of course, but the whole world. Anyway, to be here in the internet can be a resource too, and we're trying to exploit this situation. To be in the internet means that we are able to reach anyone with a connection, and to invite people with a connection, I don't want to say in a simple way, but at least in a simpler way. Today's event is the first of 4 events dedicated to music and coding. After this talk, we will have a networked concert. Well, there will be a pause at 9 p.m. Central European Time. And this structure, meaning talk and then concert, will be replicated next week. On Friday 8, we will discuss about the so-called live coding practice for making music, a discussion, again, followed by a concert. So starting from the end, live coding. Live coding means to write and run code in order to generate and then control music on the fly. Of course, music meaning in terms of digital audio synthesis. Well, this is now a widespread approach, as we will see next week. But today we wanted to start from the beginning, also in a historical sense and from some more fundamental aspects. So we can think about a sort of Gedanken experiment, a thought experiment. So let's suppose that you want to program music on the fly. In order to program music, of course, you need a language. And you need a high-level one because you are a musician. So you want to think in musical terms rather than tweaking with the machine technicalities. So you want to think in terms of maybe notes, maybe time processes. Think about canons or voice layering. You want to think in terms of instruments. And of course, this language should be interactive in order to experiment fast with your music ideas and to perform live in real time. And moreover, as audio synthesis starts historically with electronic music, let's say to simplify from the 50s, in case you want to use a language, you need this language to have constructs that mimic well-established aspects of electronic music. Audio generators like hardware stuff making signals, wiring among these generators. It's called patching typically. And maybe you want to see what you're generating. So you need something like an oscilloscope so that you can see the waveform you're producing. And you want high quality audio, the best you can get. Otherwise, you can just stick to your analog stuff or maybe other digital softwares. And of course, you need to be able to distribute these sounds in the space. Let's say maybe over 8 channels, you are in a situation with multiple loudspeakers. Maybe you have an installation, so you have many loudspeakers. You want to be able to control the distribution of sound over these loudspeakers. But if you're speaking about language, starting from our beginning, we say that you are programming, so you are on a computer. So you would also like to use all the facilities you can get on a computer, like this one: network connection, interaction with the operating system, interaction with other softwares. Well, if we pile up this set of constraints and requirements, well, this looks like a book of dreams. Actually, these dreams have been brought to reality by a software environment 25 years ago. And this environment is called SuperCollider. And if it's not enough for you, it is open source and multi-platform since almost 20 years. In these years, 2021, we celebrate, as a community of SuperCollider users, we celebrate its quarter of a century jubilee because the first release is from 1996. So there was no better idea for the first edition of our CodeFest here at the University of Torino to pay homage to SuperCollider. And so I'm really honored to introduce the main designer and the first developer of SuperCollider, that is the one who had the idea and implemented it, making available for us all, James McCartney, who has kindly accepted our invitation. Apart from SuperCollider, James McCartney has been involved in many projects during his working activity. Just to give you an idea, he has contributed to the Open Sound Control OSC protocol, which is a standard in multimedia software connection. He has been a member of the core audio group at Apple, and after retiring, is now pursuing his own research on audio programming. I may be wrong, of course, but I think that it is exactly the feature of openness in programming that pushes people interested in programming in a sort of continuous development mood, because while writing code, you can always revise, modify, redesign things by writing itself. So James agreed on discussing some aspects of SuperCollider and beyond. Before leaving the microphone to James McCartney, some final words on the organization side. After this lecture conversation, there will be a concert at 9 p.m. Central European Time, featuring a networked ensemble spread over the internet and involving the SuperCollider community, which is a very active one. And I've asked two friends who are deeply inside SuperCollider and its community to curate this concert: Marinos Koutsoumichalis from MADLAB Cyprus University and Scott Wilson from Beast Birmingham University. And of course, I've asked Marinos and Scott to join us for this talk, so they are here with us. At the end of the talk, Marinos and Scott will introduce this special distributed SuperCollider concert project. So thanks again a lot, James, for having accepted our invitation. And well, I'll leave you the word for your lecture.
Okay, so you can hear me.
I can hear you.
Okay, good. All right, well, thank you for inviting me. So I guess I will.
I can't see you. Just to maybe, I don't know if it's just me.
You cannot see me?
No, I don't know the other.
Oh, I see. Well, it says
no,
my
I can't
camera.
see either.
No.
Interesting. Okay. All right. Well, anyway, I'm gonna share my screen. I don't know why you can't see me. You could see me when I was on Safari, right? So I wonder. Yeah, I don't know what the deal is. So I wonder, maybe let me see if this is something I can resolve in the system preferences.
Okay, so maybe we can start from the end at this point. And I don't know, Marinos and Scott, if you want to say something about the concert, so we do not put pressure on James and while he's solving this issue.
Sure.
Sure.
Scott, you want to go first, or should I go first?
Well, I don't know. We can do it together, I suppose.
Yeah.
So this is an example of, I think, a kind of activity that a lot of us have been engaged in over the last year and a half, you know, which is suddenly thrown into the pandemic. And we've, you know, been forced to find new ways to try to make music together. I mean, and I think this is important artistically, professionally, but also just socially, emotionally, an aspect of mental health to do ways of doing this. And I think, I don't know about you, Marinos, but I found, you know, it's been very challenging technically in some ways, working out how to do this. We have a lot of issues, of course, arising from things like latency and things. But on the other hand, you can also very easily perform with people on the other side of the world if you're willing to work with the limitations of those systems. And you know, it's been interesting seeing how SuperCollider, for example, has fit into that, because we're not necessarily just sharing audio, and you've implemented something for this today. And we will have some, I think, somebody from Mexico, I think people from North America, we have Greece, quite a good run. I'm sorry, I'll stop talking now and maybe.
Yeah, I think it's quite of an international take. Yeah, I kind of empathize what you say. For me, it's interesting because I've done, to some limited extent, some few network things before the pandemic, like even like 10 or 15 years ago or something. And it's interesting to know that SuperCollider has been designed not from scratch necessarily, but as far as I remember it, like 15 years ago, it was already fully capable of network music scenario, different network music scenario. That was that's important. And this year, and also a bit before the pandemic as well, I've collaborated with some colleagues, you know, from Europe that used to be into network music and network streaming events since 20 or 25 years anyhow. So there is this kind of, this is what I find very interesting, that there is a legacy, you know, in network events that is very different though. Now with the pandemic, you have people who wouldn't normally do that, myself included. And they're trying to find ways, you know, to transfer their own métier, you know, in this new situation.
Yeah.
And this I find very, very interesting and also very inspiring. So when we opened this call with Andrea, invited us, you know, to curate this, to facilitate this event, I think that I want to emphasize the fact that it's actually a celebration, you know. We open to the community, so okay, send us your, just come on and let's do this together, you know. It's always a situation where we're supposed to celebrate a piece of technology.
Yeah. And maybe it's interesting to say that, you know, that community has really grown and blossomed, I think, over these 25 years, and includes such a range of people. I mean, I sometimes I think I've joked with James, you know, that all the things that are his fault, he's really responsible for in some sense. But one of the things that's interesting about the community, I suppose, is that there's something about code, and not just, you know, code in a technical sense, but code in a kind of aesthetic sense. And I always somehow feel it goes back to SuperCollider's sort of small talk influences and things like that. There's something about a certain type of design, a certain way of thinking about things, that appeals to people who use SuperCollider, and doesn't necessarily appeal to people who use other sorts of computer music environments. And, you know, when we started doing the SuperCollider symposia, we did the first one here in Birmingham, and there's been several more around the world and things, and other sorts of SuperCollider related events. It always sort of surprised me how, you know, that sensibility maybe was what people had in common. It wasn't necessarily that they were all doing the same music, you know, far from it. So I'm actually quite intrigued to see how that's going to manifest tonight, because we've just, again, like, as has almost always been the case with this community around a programming language and around coding, we've sort of thrown the doors open to whoever wants to come. And so then, therefore, whoever comes. So I don't think any of us have a very clear idea of exactly what's likely to happen.
But that's the point, isn't it?
Yeah,
yes, that's the very point. And just to emphasize the fact that
it's a party, I mean.
It's a party, essentially, yeah. And I find it very important because, like, unlike other situations with network art and network music, you know, where people were actually trying to, in other cases, you know, people are just trying to find the proper tools to implement their idea. I agree with Scott that in SuperCollider there is this certain small talk philosophy, but also the fact that if you're using SuperCollider, you are already doing, you know, network stuff, even if you don't understand it, you know, because there is this kind of server-client architecture. So you have this kind of communication between different parts within your system. So essentially, when you transfer that to a network situation, I have this feeling, okay, I may be entirely wrong here, but I have this feeling that it somehow influences the way you think. Because this idea, you know, that you're using open sound control is still there, that your messages, you know, you're a messaging thing. And if you combine it with the idea that you're using code. So I think it's all embedded in the way we use SuperCollider anyhow. The idea that you're sending messages, you know, to the language, to the interpreter, or to the server, and then they communicate with one another. This kind of distributed architecture, it's very natural to extend it, especially in a pandemic, with an ongoing pandemic.
Yeah.
Can you
want
see
to
me
say
now?
something about?
Okay, let's try.
Can you see me now?
No.
No.
Wait,
Could you see? Did you see me about a couple minutes ago?
No.
Okay. Well, all right. I'm not sure what the problem is. I mean, my camera light is on and my video is supposed to be working. Let me.
Maybe
Is that
it's
changing anything?
Because it seems that we get the turn while speaking. I see Marinos right now.
Yeah. So yeah, my camera should be working. I mean, it's on, so I'm not sure why I can't.
Because we made tests before. Actually, it worked.
Okay. Well, I mean, hopefully my screen sharing will work, and then you can at least see what I'm presenting.
That's it. Otherwise, I mean, you can send me the. I don't know if it's not interactive. You can send me the slide, and I can try sharing them.
Well, can I try sharing now?
Yeah.
Yes.
All right. So let's do that. Oh, okay. Now I'm back to where I was before, and it won't let me share again. Okay.
Maybe Marinos, we can try stop video. I don't know if it might help.
Yeah.
James,
if I go in Safari, there's no share screen button, but here I have a share screen button, but the dialogue, it's grayed out and I can't share it.
Oh, okay. So, well, maybe is it possible for you to send me the slides?
Yeah. Yeah. Let me. Okay.
it's strange, James, because the screen sharing was definitely working.
Yeah.
I don't know what changed.
I mean, I did have a problem at the beginning of it, and then it went away, and now it's back again.
Maybe it's worth, since we have time, to, I don't know, maybe log out and log in again through a different browser. I'm using Opera.
I
Seems
think
to be stable.
If the thing is, in Safari, there's no share screen button at all.
Strange.
For me.
Maybe try another browser or Chrome or
you don't have so there's no Zoom link where I could just use the Zoom app.
I had the same question before.
I don't think so.
All right. Yeah.
Or Firefox or something
get
else.
The link from the top left. Yeah, I can't see any link here myself. Maybe the host can.
Morena, sai se possiamo, se c'è un link diretto?
Per Zoom?
Sì.
Sì, ci penso io, mando l'invito a James, giusto?
Sì. Sarebbe ottimo.
I'm emailing you the slides. It's big.
Yeah, I
she
think
will send you maybe a link, James, in a while.
Okay.
Yeah, we're sending the Zoom link to James.
Okay.
Okay, so how many people are involved in the concert?
something like 7, 8 people in total, including ourselves.
Okay.
And the idea is to start, I mean, a very interesting thing with that kind of concerts is the latency thing, actually. And I've participated myself, in a lot of such things, the last couple of decades. And it's interesting because in certain kinds of music, and I mean, as far as I'm concerned, with my own approach, I find it much more interesting if there is a lot of latency. So I've been in situations where, you play something and you actually listen to yourself after 30 or 40 seconds. I find it very intriguing. And it's quite interesting because in other music setups, this is a major problem. Of course, we don't have that much latency today, but I think that it's very interesting to see how people react to this using an environment like SuperCollider. In a live coding setting, which is not necessarily rhythmical. I stress this because these days, live coding is often associated with algorithm. While live coding can be much more different things than that, actually. Not all of these things are associated with, just-in-time sound, right, Scott?
Yeah. In a weird sort of way, I think of it a little bit like, music written for, acoustics with really long reverbs or something. I mean, when you start to get music written for cathedrals and things, of course, they have to take into account the fact that the sound lingers around. So you get different sorts of music than you get outside. And, I know sometimes there were periods where people talked about inside versus outside music. So I just think it's the same in a way. There's just this kind of really long latency. And so people have to do different sorts of music that don't require that kind of tight synchronization. I was wondering if, maybe you wanted to say something about the code projection, because I think this is also something interesting with live coding. There's traditionally, if you were doing it in person, people would often project their screen so you could see the code they executed, but also, not just that, but what they were typing, what they were thinking. And there's often an interesting aesthetic about it, that it's, that in a way, like watching people think through things, change their mind, it's almost like part of the music. It's like a counterpoint or something. And also somehow in some events, it's almost more like a performative situation, and it's less about the musical result than sort of experiencing this process together. And so you've tried to come up with a solution to give some bit of that.
Yeah, it's been tricky. It's been tricky, not technically. It's been tricky, like conceptually. Like, okay, what do you do? I mean, it's a festival about code, right? So you want to project the code, but in what fashion? I mean, we don't essentially. We wanted to do something different, something which is kind of, you have SuperCollider and we do a party, as Andrea said, and we try just, to create a new situation that has to be networked, but also has to be a lot about code. And it's interesting because in traditional live coding setups, the idea is that you can actually see the code projection as people are writing the code, but it's just typically 1 or 2 people, writing the code, they make mistakes, they correct them and so on. So you can see the process. I came up with this very different solution here. I have my own server which I use to facilitate, artistic projects and situations like this, actually. So I run a small script in there, and the idea is that each user has this piece of code that will always send the code that is executed online. So you have a projection, just the code that's executed, not the code that it's typed. The code which is actually executed and has no error and works, and it's responsible, for what will happen in the next few moments, seconds, minutes, who knows, depends on the code actually. So all this code is sent to my server, and there we can see, like a waterfall of code associated with the different users. So you can actually see who does what. And I hope that this will give it will somehow enhance the experience. I would suggest that people, at least this is what I do, I sometimes look at the code, I sometimes only focus on the sounds and forget about the code, then I come back. I think it can create a different layer when listening to such things.
Good. How are we doing, James?
Well, I'm in Zoom, and I
can see you. Hey! I can see you and hear you, James.
I can see you.
Welcome on board.
Brilliant.
All right.
Bravo.
Well, let me try and share my screen now.
Okay.
If this will work. All right.
Well, at least we see you.
Yeah.
There's
Okay.
something here. Yes. Yes.
Okay.
Yep,
let me
it's
do-
here.
Yes.
Yeah. So, ladies and gentlemen, James McCartney.
All right. How does that look? Can you see it?
Yeah, fine.
Yep.
Absolutely.
All right. Let me. All right. Okay. So. All right. So this is what I'm going to talk about. So I'll give a prehistory and origin of SuperCollider, and then I'll talk about a project that I did after SuperCollider called Sound as Pure Form, and then sort of what I've been up to recently. This is me from 79 to about 84. So I was at the UT Electronic Music Studio doing electronic music, and and I bought an Insonic Mirage sampler, and I wanted to generate samples for it. So I wrote this program called Symphonics that had 8 modules, and you could patch them together and draw envelopes and things, and then create samples for the Mirage. And I tried to sell it, but I only sold 2 copies. One was to Ivan Cherpin at Harvard, but anyway, so Serge Cherpin's brother. Then in 1990, I wrote a program called Synthomatic, which was more well, I had learned C sound, and C sound was like assembly language, and it kind of annoyed me. So I wanted to have something where I could write, algebraic expressions for generating sound, and so that's what this was. So at the same time, I was working for this company called Level Control Systems that did digital audio mixers, and I wrote this program called Q Station for BOS, and this company eventually got acquired by Meyer Sound. And I was using Macs at the time, so I wrote these objects for Macs. First, I wrote an object called script, which was a little MIDI sequencing language, but it was not really a programming language. It was just a script for generating algorithmic sequences. And then I wrote a language called Pyrite, which was sort of, the Pyrite is in the lower half here. It was an sort of a language-like scheme in that it had closures and it had a real-time garbage collector. So this is the same function written in both script and Pyrite, but script is just, it's not really a programming language. It was just generative MIDI. So then I was working with a choreographer, and on a piece that was where I was doing granular synthesis, and I was using Synthomatic, which I'd written in and I was rendering it on a Mac 2 CI, and it was really slow, and it was taking me a long time. So Apple came out with this PowerPC Mac, and it had floating point, and so I went and I bought one the first day it was available, and I recompiled my program, and it was running 32 times faster, which was faster than real time. So I decided, well, I'm going to take Synthomatic and combine it with Pyrite and make a little real time audio synthesis language and see if I can make it work. And so that was SuperCollider version 1. And I put that out, and then I got invited to Berlin by Janis Zanos, who was at the Musicology Institute there in Berlin, and we did a project where we were doing we did a concert in a empty indoor swimming pool, and I was writing software in SuperCollider version 1, it was just, you know, kind of frustrating, and it made me realize the limitations of version 1. So it just wasn't able to express a large program. So I decided to rewrite the language based on small talk, and that became SuperCollider version 2. And this is something I was thinking at the time, and which was that the main idea behind SuperCollider is to bring to bear as much power of abstraction as possible from the programming language world to the problems of musical synthesis and composition. And I have tried to make the choices that would make SuperCollider as powerful and elegant as possible while remaining efficient, real-time, and interactive. But these choices sometimes conflict with the immediacy and accessibility to users unfamiliar with programming concepts. There are already other applications that cater to the needs of people who require more direct interfaces, and eventually some of those users may find the expressive limitations of the environments they're using and become motivated to learn something more. So that's sort of the idea I had behind making SuperCollider, why I thought, you know, it was something useful to make. So that was version 2. Then I was having trouble with, you know, SuperCollider 2 could sort of just do one thing at a time. You could start something and you could start something else, but it was running the audio synthesis at the same time as it was doing any kind of user interaction. So that was not an ideal situation. So SuperCollider 3 D5 was this attempt to separate the real-time and the non-real-time aspect of what it was doing. And so there were 2 virtual machines. One was handling real-time and another was handling non-real-time stuff like the user interface and loading files and stuff. And it had an image synthesis part, and it had this animated user interface. So this is some of the image synthesis output that it was doing, where you would run unit generators, but instead of producing audio samples, they were producing pixels. And also there was this animated UI. So it was interesting because I got pretty close to inventing immediate mode user interfaces, but I didn't quite get there. Which is a kind of user interface paradigm, which I'll talk about later. So this separation wasn't entirely satisfactory. The virtual machine that was running the audio was too heavyweight, and also it was running on macOS 9, and that was coming to an end, and because macOS 10 was just released, and so I decided to take advantage of macOS 10 being Unix, and I came out with SuperCollider Server, which everyone called SuperCollider version 3, but for me, SuperCollider version 3 was this thing that came before it. But I finally relented and called it version 3 because everybody kept calling it version 3. So SuperCollider Server was separated the synthesis engine and the language into 2 processes, which gives you crash protection. So if the audio synthesis part crashes, then the language, you know, your score is still running, and if this score crashes, then whatever you had on the audio server can still be running. This also enabled network performances, and it enabled being able to have you know, one client to many servers, or many clients to one server, or many clients to many servers. So yeah, you had a client and a server, you know, communicating between each other with open sound control over UDP. So you just have all these kinds of architectures going on. So then I joined Apple, and just experimenting around on myself. I was doing various, you know, sort of projects but I hit on this one thing called, which I called sound as pure form, which was also known as SAPF. And its name is about what it feels like to operate interactively on sounds and the structures that produce them as values. So it's like it's a functional language, so everything's a value. It's concatenative language, which I'll talk about a little bit later. And its syntax is postfix, like fourth. So you would do like, 2, 3 plus to do 2 plus 3. And function composition is concatenation. So if you put words one after another, that's composing them as functions. And the audio and control are represented by lazy, possibly infinite lists. So lazy means they get evaluated when their results are needed. So you can just have this infinitely long list and keep asking for more data at the tail, and that's the way audio is represented. And it has this auto mapping feature, which is a feature from the APL or J programming languages, which makes it really able to express complicated things in a very short amount of space. So a concatenative language is one where the terms and functions are the terms are functions, and concatenation of those terms are function composition. One thing that's interesting about it is that it's evaluated left to right instead of like something like an algebraic language where you're nesting functions. It's evaluated inside out, or inside parentheses to outside. And so it's easier. It's easier to write because you always are operating on the last thing you wrote. So you can just keep streaming along more functionality onto the things you've already put on the stack. Multiple return values come for free, and there's no operator precedence, and no parentheses or commas are required. So it's a really light syntax. It can be hard to read if you're not used to it, but I got pretty used to reading it. So auto mapping is this feature. It's like multi-channel expansion that SuperCollider has on steroids. It's a feature from APL, and what it is that any function which operates on a scalar value, if you pass it a list, will automatically operate on that list, on each value in that list, and produce a list of its results. And in this language, every function is like that. Not like in SuperCollider, just unit generators work like that. But in this language, every function works like that, unless there's a few functions that specifically defeat it for certain reasons. But basically, every function in the language works like this. There's also this at operator for doing implicit nested iteration, like you can do cross products and things like that by using this each operator. Also, you can loop over a deeply nested list. Like if you have a list that contains a list and you want to iterate over the lists that are contained in the top level list, you can use this each operator, and it will operate one level down inside. And so what it means is that you never have to write loops. Everything can be written like scalar expressions, and so it makes you able to process whole structures with like a single function call without having to write loops over them. And even though it was a very small language, it turned out to be pretty fun to write little sonic experiments in, and I used it for quite a while, just playing with. And because of the auto mapping, the programs can be really brief. And there's a SoundCloud account that has examples of it called, where the username is sound as pure form, all run together. And there's also a few more, and then another account that I have on SoundCloud called LF Noise. So you could, and also these on the sound as pure form page, all the sound examples have the code that produced them underneath. So, so this is what SAPF code looks like. So it's postfix. So I don't know if it's large enough to see, but basically you have the parameters for a function come first, and then the function happens, and then so this is like a sawtooth wave, and it this output gets multiplied by 2, and then all this stuff goes into a sine oscillator. So this is all the frequency calculation for this sine oscillator, which gets multiplied and then goes into a comb delay and then played. So this is the analog bubbles patch for SuperCollider in one line. These are all like SuperCollider examples, basically. So the equivalent programs tend to be a lot shorter. And also because it's using lazy lists, you can write an expression and it will print out the result, and it'll show you the samples that you're going to get. And that's a list, and then you can just keep operating, and you can look at the samples that are going to be produced while you're keep adding on functions to it. So, and then you can play them at the end. So that it's very interactive in that way. Another feature of SAPF is that it logs everything that you do. So every time I execute code, it's written to a log file, and my log file has everything I've executed for the last 10 years. And it's 151,000 lines long and 5.1 megabytes. So I can go back, and find out what I was doing on a certain day and play it back again. So another thing I did with SAPF is I took it and I made a domain-specific language in C++ by keeping the execution engine, eliminating the parser for the language, and rewriting those all the functions as C++ functions. And then I was able to write in these same programs in C++ and have these infinitely lazy lists in C++ where I could just write functions and do it. That was, and then SAPF was like a library. I could link it into another program and use it just by making function calls. But it's still using precompiled unit generators, so like SuperCollider. It's just chaining them together. So then after, then I retired from Apple, and so after SAPF, I've been sort of pursuing other kind of interests that are sort of based on the ideas that I got from it, which is having a programming language with lossless history, so that while I'm editing, SAPF would log everything I would do, but if I would want to be able to, like, if I'm changing a function and listening to it and then going back and changing some parameters, or adding some function calls in and going back and listening to it, I want to have sort of undo and redo in that kind of process. And so I've been, I implemented a way of doing, unlimited undo and redo, so you can get back to any point in history that you've been at. And if you go back and undo something and then make some changes, and then now you can't redo back to where you went. Well, you can, because I saved those changes, and there's just a linear history that you can still undo and redo as normal, but you can also move linearly through the history, or even randomly access the history and find places that you were in the past. And I wanted to unify user interface and language as much as possible. And I want to have code as prototypes that I can clone and modify. Also, I want to be able to, instead of having precompiled unit generators, generate synthdef code natively. And also I want to integrate reactive data flow, which is another whole topic, which I'm not going to go into, but basically it's like spreadsheet kind of evaluation where you change things and things react to them. Another thing I do, well, since I'm for the last few years of playing this piano that I have, so that's another one of my research things, is learning this piano, which is an isomorphic keyboard piano. But anyway, so first I'll talk about DSP code generation. So SuperCollider synth-defs and SAPF graphs are graphs of precompiled unit generators. But now I've written a compiler and audio engine so that synth-defs can be compiled to native code for these new languages I've written. And actually, I've written the system about 4 times. So you write code similar to SAPF, but it results in compiled synth-defs instead of a graph of unit generators. So this is what the output is like. It's just, it's C++ code. This is the analog bubbles example from SuperCollider, just as C++ code, or just the main loop part of it. So as the front ends for this code generator, first I had this little functional language, which is, so basically SAPF is, it is kind of hard to read because you have to know how many arguments every function takes in order to be able to read the code. If you don't know the number of arguments the word requires, then basically you can't parse it. So this sort of goes back to a more algebraic kind of approach, but I do have this thing where I pipeline the output of one function into the next function as a first argument. It's as if there was a dot here. Like in SuperCollider, you can do that with putting the dot, to have the output of one method go to the input of the next. But here there's no dot. It's just they're just strung one after another, and the output of one function goes into the next. So this is the bubbles patch in this this little language. But I wrote a lot of versions of the DSP compiler and a lot of front ends. So I wrote it so you can write C++ functions, similar to the way you can do in SAPF, the C++ library for SAPF. You can do it in this language, and this will generate a native code output. There's also a Lisp-like front end to it. I wrote the whole system in Python, so the compiler is written in Python, and you can write the bubbles patch in Python, and it will generate C++ code that will run all of these will work in the same little synthesis engine backend that I have. And then the more recent one is this. I have now an object-oriented language that's it's got multi-methods, so it's multiple argument dispatch and multiple inheritance, kind of like the Dylan programming language that Apple worked on back in the 90s. So it's a very rich language, and you can express a lot. So in this version of the language, the compiler is written in the language. Just like it was for Python. In the previous ones, I'd written the compiler in C++. So there's some differences it's similar to Faust in that it generates code from a language description, but it's different in that signals are multi-dimensional arrays of 32 or 64-bit ints or floats, and possibly complex and rational numbers in the future. I haven't added that yet, but in the language side of it, they are expressible. And you can have subgraphs that run on demand, like demand rate unit generators, or pause in SuperCollider. So you can have this sort of multi-rate things, or things where parts of the graph are turning on and off. And unlike Fausted, there's no block diagram algebra operators. So you can handle all that with auto mapping and reduction, and I think it's a lot easier to read. So another sort of direction is user interface. And I'm just trying to be able to integrate user interface and code to become sort of a unified thing, and as much as possible. And also there's this thing that's come along called immediate mode user interfaces, which make writing a user interface nearly as easy as printing your data, because what it does is, instead of creating a bunch of objects that are your user interface objects and then trying to communicate with them to between them and your program, what you do is just traverse your data and print it to the screen every frame. And so basically you're just drawing to the screen what look like user interface widgets, but they're really the output of function calls. So it makes for very dynamic user interfaces. Yeah, it's pretty cool. So first, this was before I had done immediate mode UI. This is just a normal UI, but it was sort of this idea of taking nested code and representing it as a user interface. And in a way, it's a lot like this project that, called Scheme Bricks that I had seen. But then later I wrote an immediate mode UI, and I made this user interface, which also has a history. And it's really pretty, but the thing is that the graphic library I'm using is now not supported anymore. So I've been moving to something called Dear I Am GUI, which is a sort of an open source immediate mode user interface library. It's not as pretty, but at least it's supported. So if there's time, I can do a couple demos if you're interested.
Sure, we have time.
I am interested, yeah.
All right, let me okay, so this is that first user interface, and there's really not much to demo with this one, other than you can sort of treat code like prototypes and sort of clone it. Yeah, so this one didn't go very far, but it was one of my experiments. And then I wrote this one, which is an immediate mode user interface. It's got a history over here. Yeah, this is like the bubbles patch, and this is like inputs. You can control things, and then here's the implementation of it, which is you can sort of drill down into these how all these functions that in the code are implemented, including the ones that it's calling. So I can go down here, and the other thing is that you can take any expression that's sort of displayed as user interface, and you can go back to a text mode representation of it, and the text mode can be displayed in like a Lisp form, or like SAPF style, or this pipeline style, or like a sort of a Haskell-like style. Or as a user interface. So and then I've got this history here. So if I do things like I change things, there's this commit button, which should go away, but because it should just do things as you do them. But so I can do undo, and it goes back to the state that I was in, before. If I can, so I could go back here and I could, open something, and then commit that. And if I undo, I go back to that one. But so now, but I can still jump to this one. I can sort of randomly jump to any of the previous history that I was at. Yeah, so, and it can do sort of, graphics stuff, Anyway, yeah, so this is an immediate mode user interface, which means that every frame, this is traversing the data and drawing the user interface. So it's quite dynamic, and you can just sort of change everything about it every whatever. So yeah, it's very dynamic. So anyway, so that's that one. And then well, since that library's sort of not maintained anymore, I'm switching over to this, which is Dear IMGUI, which is an open source IMGUI framework. And this is sort of not very far along, this one, but I've written some user interface widgets for it. Anyway, that's I mean, so the other thing is I don't know if I can do audio through this. Is if I play audio, how do I make it come out? Is that come out?
You're in Zoom, so we can try at least.
Yeah. All right. So
there is, if you James, if you try on the share screen, there should be an option to share audio. We did it yesterday. I don't have the application open, but there is a small arrow.
You'll need to stop sharing screen, I think, and start again.
Yeah, you do.
Bottom you select share audio.
You just select share audio.
I see. So where would that be?
In the share screen.
There's a tick box, I think, at the bottom.
Oh, I see. Share sound. Okay, cool. All right. So please install the Zoom audio device. Okay.
Yeah, of course.
Now we see again.
Did that do something? Well, we'll find out here. Yeah, okay, so let me just see if this works. Well, I'm not hearing anything now.
Either.
Yeah. What if well, maybe I would have to have quit Zoom at that point.
I don't know if you need to quit Zoom, but you need your audio application has to go to Zoom audio device. And then in Zoom, you can set the setting of what Zoom audio device
I see.
Which is next to the little up arrow next to the mic thing lets you set that usually.
Oh, the up arrow next to the mic, it says select a speaker. You mean?
Yeah, so that's what you want to listen to.
Well, it doesn't. I don't see Zoom audio device as a choice.
No. So that should be what you want to listen to, but then your software needs to use Zoom audio device as the output.
Well, my software just uses default audio device right now, so I wouldn't be able to change that.
If you're sharing screen, it should be that. But like with SuperCollider, I always need to restart the server if I'm relying on that being the default audio device. So I don't know if it's like bound to a different device and you need to restart it or something.
Okay, let me try that. All right. Okay. All right. So let me go back to sharing and share sound. Okay. All right, so let me. All right, so are you seeing my screen now?
Yes.
Yes.
All right, so let's try this again here. How about that?
Yep. I can hear it.
Okay, all right.
It's bubbling.
Yeah, right. That's bubble.
That's a classic. That's
right.
a classic we know.
Right. Yeah. So this is yeah. So this is SAPF. Is the font size big enough? I can make it bigger. So yeah, if I just do like, if I just type, you know, a sine oscillator, then I get a list, and these are the output samples of that sine oscillator. And if I then if I like, I can multiply it. I still have those samples, and I can just play the sample that's the list that's sitting on the stack, and that's just a sine wave. So if I do something like, yeah. So let's see if I do. So if I do, yeah. So like this is just a function that returns a list from 1 to 10, but I can do like 1, 1, 10, 2, 2. And what this means is I'm producing a list from 1 to 10. So basically the second argument of this 2 is this list. And so what I'm going to get is a list of lists. So I have a list. Well, first I had the previous one on the stack already. So what I have
so it's like a list without the parentheses, James, right?
Yeah, sort of, but it's backwards list.
Okay.
The function comes last.
Well, it looks like I have programmed in PostScript, and actually I think that's the same logic.
Yeah,
because
it's just exactly like PostScript.
Yeah.
Yeah, right. So here's a list from you know, of all a list of 10 lists from 1 to 10, and so you can do that with music compositions. You can write a function that generates a, you know, a composition, then you can give a list of seeds or something like that, and you'll get a list of compositions out. And then, so there's a lot of these things that are done that way. I mean, there's
that's a course on synthesis, actually.
Yeah, it's pretty easy to write things really briefly, and so I did a lot of it. There's a lot of SuperCollider. Well, here's Bach. So these are lists of notes that are sort of compressed with this algorithm. That anyway, but these are like, this is generating lists that are being fed into an oscillator. So this is really working, instead of like being more like a MIDI notes. These are really like this is a very complicated envelope generator in a way, and it's doing all this kind of cycling of things. Yeah, I could go on a long time about this, but yeah, this is sort of like produces a list of. This is also a SuperCollider example, but the way it's done is it's producing a list of these. It's a list of compositions that are just getting played one after another, basically. It'll play one for 45 seconds or so, and then go to the next one. Anyway, so yeah, that's SAPF, and that's about it. I think for let's see, yeah. So yeah, that's what I've been doing.
Yeah, thanks a lot. I'm clapping my hands. It doesn't cannot be. I think everyone is clapping their hands. Actually, I think maybe we can have a small discussion. I was curious to understand this because you're developing many projects and it's a form of specific computational creativity. I mean, I don't know if you have ever published a record, but actually it seems to me that your idea is to make music while writing, while thinking. And I was curious, you developed these projects because you saw some limits in SuperCollider, or just because you wanted to go over, so beyond SuperCollider? I mean, is it a way to go over certain limitation of SuperCollider, or simply to do things in a different way?
Well, it's just I have this sort of idea of my ideal way of working, and I'm trying to approach it. That's my main goal is I want to be able to have something that's just really interactive in a sort of intimate way, where I'm just like I'm just manipulating the audio as as directly as possible, and I'm getting as results as fast as possible, and yeah, so I can explore as farther.
Yeah. Well, actually, I programmed in PostScript, and I really liked the way of writing in a concatenative way, because I had this idea of following my thoughts in some sense.
Right.
But as you said, it's a little bit more complicated to read it back.
Right.
Because when you read back, actually, you go backwards. And I don't know, actually, if this is something that you just get used to, or
well, I think the new language I have, which is it's still you still concatenate functions, but everything's not a concatenation. It's easier to read because you have to parenthesize the arguments. Basically, you have the main thing you're transforming keeps getting pipelined along, but all the options are encapsulated in parentheses so that you can separate the options of what you're doing from the main thing that you're doing, which is the sort of the problem, I think, with the purely postfixed way of doing it, where if you just drop into the middle of some code, you can't tell, well, is this the main thing I'm doing, or is this just setting up some sub thing that's going to feed into that? So I think
I have another curiosity that maybe Scott and Marinos can join us. One of the, let's say, limits of SuperCollider, which is related to an issue related to performance, is that you do not work directly at the sample level. But in this case, are you working at the sample level, or are you can you access?
I can, yeah. I can even do that in SAPF, where it's to some extent where it's unit generated, because I have these lists. So one thing, there was a paper, I think, given in Hong Kong by Eric Lyon, which was pretty interesting to me because he called it sonic composting, I think, and it was the idea of taking these taking samples and applying processes sort of at random to them, and then just keeping doing that until you get something out the end. And so I did that in SAPF. I have this thing where I generate short little snippets of noise, only maybe a few samples long, and I start repeating them and concatenating them and filtering them and delaying them and flanging them and doing all kinds of processes to them. And, they become tones, and they become, or these noise textures or whatever. And, and they just keep becoming more and more complicated. And so that's one way of working at the sample level, but also you can do things like, when I'm compiling these, I mean, you're not stuck with whatever unit generators are done for you. I mean, if you want to write one, you can write one just like you could in Faust. You can write your own little unit generator, because yeah, in this new language, there's no real unit generators. It all goes down to just operators and delays, and so and everything's compiled up from there. So an oscillator is just, is not the fundamental thing. The fundamental things are just plus, minus, and delay or whatever, sine or cosine or whatever.
Okay, maybe my last question. One of the things I like in SuperCollider is that you can develop actually large projects because you can work in a very organized way. It seems to me, maybe I'm wrong, that in this kind of language, you're focusing on the creative aspects. So in embedding, a certain composition into well, someone said once in relation to SuperCollider, maybe to your examples, maybe it was Alberto De Campo. He spoke about haiku programming, which is something I really like, because the idea is that you can compress a very complex behavior in a very simple format. So, do you think there is a different focus on this kind of project in relation to comparison with SuperCollider?
Well, I mean, I think it's going from the same kind of motivation. It's just like I've just over time, discovered more expressive ways of doing what I want to get done. I mean, I really like APL because I mean, it's it's unreadable for most people, but and so I've made it, I think more readable by using a more common syntax, but it's the same idea of being able to operate on large structures at once without having to write loops and stuff like that. It makes your programs be able to be really brief, and so you can write a larger program in a smaller amount of space. Also, that I wrote the compiler in the language to make sure that the language was expressive enough to do something really complicated. So, so it is this newest language, the sort of multi-argument dispatch one that I'm working on it's capable of larger projects than SuperCollider is. I think, so.
I think Scott if I may intrude, yes, I mean, I guess it's also a personal thing, all of us have our own way of doing things. What I love in SuperCollider is that it's very flexible. So it's kind of, it has this Python quality. You can easily prototype things. You can do things, code is easy. There are many different ways to express yourself. That's good. But on the other hand, I kind of don't like it as well. It's very good and suitable for certain kind of things, but my personal way of doing things sometimes requires something like C++. I'm actually a big fan of C++, especially modern C++, and with all these new features, write value semantics and all this. I find them brilliant. Actually, you can have lots of control, and fine-tune your code. You can have code which is perfectly optimized and really good for some particular task. So I guess that this is very important. I mean, I myself sometimes have been in a situation where I have an idea about this project, not about the project itself, and how to achieve this goal, but also have the idea of how I want to structure the code to achieve this goal. And C++ way of doing things sometimes is very good. You can have all these object-oriented features, which they're a bit idiomatic. But I like this kind of pragmatism behind C++ in the way that you can combine, object-oriented programming with other kinds of programming, using with a little bit of STL in the algorithms and all this. And then you have all this, but I still want the engine of SuperCollider, because it's optimized also to do very good sound. And I think that when working with C++, this is kind of a problem. There are a lot of libraries to do sound synthesis in C++. But SuperCollider server is could be me, but I think that it's a very good server. Actually, you can do amazing things with it. So I sometimes combine the SuperCollider server with code in C++, and I try to embed it here, which is it's a bit, in a sense, it's somebody could say that it's a bit stupid, because essentially what I'm doing is that I'm only keeping the server, and embedded into another program, which is kind of an ad hoc SuperCollider version that just do a specific thing, which I could do with SuperCollider as well. But there are certain things that you can do this way. I mean, the other obvious approach, which I've done sometimes, again with obvious drawbacks, it's also a question of what somebody is used to doing. But the other way is that you can create always a C++ program, and you can call it from SuperCollider. So SuperCollider can be like the interpreter, can be some kind of a platform that calls other programs.
Right. Well, the back-end audio synthesis server or library that I'm using right now is just a library. And it's implemented in one file, so one big file.
You just include it, yeah.
You can just include it in your project, and then you can send commands to a server. And
but is it available? I mean, is there a link where we can find more about?
No, it's not. I'm not done with it yet.
Okay,
it's just part of my own project. But yeah, so probably at some point I'll put it out on GitHub or something like that. But
at some point I had encountered. I forgot his name. Anyhow, I had randomly encountered this guy who worked in this C++ library with very similar features like SuperCollider, but he didn't design it as a standalone sound synthesis thing, but more as a library that you can embed in other C++ projects. So one of the features that this had, which I find pretty interesting, is that there was this notions of different domains. So you had, like, for instance, an oscillator, could be like a sine osc or something. And if you would work in a time domain, it would obviously be like a normal oscillator, but you could also use it in a spectral domain. So you could actually use all the U generators that were available in either the spectral domain or the time domain. And there was also this very nice option that you could also select the granularity. So you could either work with real numbers, double float numbers, like single float numbers. You could also work with complex numbers. Not sure how what happens underneath. I didn't check this part of the code, but I find this quite intriguing also. There are like, what I like also in your approach, James, is that it kind of exhibits the fact that there are lots of complex details in there and decisions, that sometimes you just want to hide, but some other times you just want to expose. Because in all these hidden decisions, the possibility of alternative ways of doing things is also to be found, right?
Right. Well, that's the thing about making a decision, is that you in that word means cutting off the other way, so.
Yep. Yeah, but there is this paradox. There was this sociologists that talk about this, openness through closure. So you make a decision, you cut all other things apart, but you are also enhancing the complexity of this small thing. You are opening a small world.
Right.
And I think this is pretty much what you are doing.
Could I ask something maybe just related to that? And actually, I think, to be honest with you, I'm going to have to actually go and relocate before the concert, or I'm not going to be able to go.
Yeah,
so
sure. Yeah.
But James, sorry about that. Yes, I mean, just looking at that talk, and I mean, also just other times that we've talked, James, it just strikes me that it's almost like a history of you changing your mind about things. So you do something, you learn something from it, and then you change your mind. And I think it's been one of the unique things about SuperCollider, and maybe if we can consider things like SAPF like in the same lineage or family or something, it's quite unique. I mean, I can't think of any other language of any sort where you have a version 1, 2, and 3 or whatever we want to call it, where they really are like these huge kind of breaking changes.
Right.
And I mean, obviously that's anybody who paid even the light attention, like for example, that I did to the Python discussions when they tried to make less extensive breaking changes. I mean, you can understand the problems of that. But I mean, I've always thought there's something very, very kind of brave about that, and very in keeping with the spirit of exploration. And we should change our minds. We should try to do something differently. But so you're at this now. I guess maybe my question is, what's next? Like, what's the problem with this? What's the kind of the
well,
seed
it's
of
just
the
you know,
direction?
it's making, you know, taking all these ideas and making a workable system that you know feels good to use. I mean, you know, it's it's a lot to bring together, you know, an audio engine and a language and a user interface, you know, and well, I didn't talk about trying to integrate a database into it, but you know, trying to integrate all these things into one thing and have it all work well, you know, is just something that takes a long time to get it to gel. I mean, the thing is that, you know, Synthematic was, I mean, not Synthematic, SAPF was really, somehow it was just one of a number of projects that I worked on, but it somehow it gelled and it was like something that was really fun to use. But so yeah, just you know, I'm still, you know, I stopped using different approaches because they didn't work in some way, you know, they had some problem. And so it's basically it's just working out problems in these architectures that I'm trying to develop that where I launch into them without having solved all the problems. And then I realized that, well, some of these problems were solvable or easier than I thought. And some of them that I thought were going to be easy were not easy at all. And so I have to take a different approach. So.
Sounds like a good metaphor for life, really.
Yeah.
Okay, so maybe we can finish here our conversation. Of course, we'd like all the community to keep on talking, but you know, there will be other occasions for hopefully to speak with James McCartney. So thanks a lot. So we leave our Marinos and Scott to go preparing for the concert. So thanks a lot again, James. I'm again clapping my hands. It's been really a pleasure, and it's been really a nice an important lecture for our CodeFest. So really a great occasion.